Alright guys, for this one we're going to use a triangle shortcut proof to show that this angle is congruent to this angle. And so first and foremost, let's get an idea of what we're trying to do. Here is the first angle that they named, and in the pink triangle here's the angle that they're trying to match it up to. So we've got the angle at vertex A in the original triangle, and then again the angle at vertex A in the new triangle. And this makes sense. We just want to use a triangle proof in order to do this. So the proof method for this one is actually going to be outer triangles, and we're just going to find the lengths, and when we do that it allows us to match up the sides. That didn't work. Let me see here. I want a line. There we go. So we just want to match up the sides of these things. So we just want to, all we're trying to do is show that all these sides have exactly the same length. And we can use the dimensions of these things in order to show that. So let me fix here. So we're going to find the lengths of each one, label those lengths, and then match them up with the new triangle and make sure that those lengths are exactly the same. So let's look up here. We're looking at how far over does this go. It goes from 0 to 2, so that has a length of 2. This one from vertex B down to vertex C has a length, goes from 13 to 3, so that's got a length of 10. And so what we just figured out is that BC has a length equal to the square root of this thing squared plus this thing squared. So do that off to the side. That's 2 squared plus 10 squared. And if you simplify that, that's going to end up giving you root 104. So I don't really care if you simplify. You can if you'd like. But again, we're going to take that and match it up with one of the other lengths on the other triangle. Let's keep working on this blue triangle here, the original. So I'm going to look at this length down here from A to C. So we're looking at this length right here. So that one goes up 3. That's got a length of 3, and then it goes over 2. So the length of AC is going to be, this was BC. AC is going to be 2 squared plus 3 squared, the square root of that. And then 4 and 9 is going to give me square root of 13. So AC is root 13. Last one goes straight up from A to B, and it goes from 0 up to 13, so it has a length of 13. So what I've got to do, these are all side arguments. Notice that. So this is a side, side, side proof, and we're going to try to match those up with the lengths from the other triangle. So let's go ahead and do that. First one we're going to work on is let's go AD. That's the first one we're going to work on. So from AD, we're going to go down and over, figure out what those dimensions are, and then we can find our lengths using those outer triangles. So let's go ahead and do that. So from 0 it looks up to 5, so that's got a length of 5, and then the height of that thing is 12. So what is this? AD equals square root of 12 squared plus 5 squared. If you do the math on that, that's the square root of 169, which gives me 13. So that one matches up perfectly with AD or AB. AC corresponds to this little side over here, so I'm just going to do this outer triangle right here. So that goes from 0 to 2, that's got a length of 2. This guy goes from 0 to 3, that's got a length of 3. So I've got AE equals the square root of 2 squared plus 3 squared. That's going to give me the exact same result as up here. So AC matches up perfectly with AE. And then the last one, BC. That's this triangle right here. And we're trying to match that up with DE, it looks like. So I've got to go from 3 over to 5, which means this has a length of 2. And then this guy right here, no longer 12. That was used earlier. I go from 12 down to 2, so that's got a length of 10. So it looks like DE is going to have a length of 10 squared plus 2 squared, which again matches up perfectly with BC. So this is DE. what we did there was show that these two triangles are exactly the same. And it makes sense. We just rotated it, so we didn't change any of the dimensions. So we just need a formal conclusion here. So therefore, by SSS, that's the shortcut that we used, triangle ABC is congruent to, and we got to be careful about how we match this up. ABC matches up with ADE. So it's triangle ADE. And then the last thing is we didn't care about the triangles necessarily. We actually cared about the angles. So do these angles match up? Well, CAB goes third, first, second, and that better match up with third, first, second, or in other words, EAD. So this is where the CPCTC comes in. By CPCTC, I know that my two angles, CAB, that I wanted to match up actually are congruent.